Yellow, red, blue, aquamarine, magenta, violet. What is it that makes one colour different from another? To answer this, we should do an experiment. I've taken the lights from my bicycle, one red, one blue, and I've put fresh batteries in each one, and we'll turn them on and see how long it takes for them to run out. It takes a long time, but if you wait, you always find that it's the blue light that goes out first. And this tells us something very deep about colour. It means that blue colour is higher in energy than red colour. The blue makes the batteries run out faster. And this is true of all colours. Every colour has a different energy. So from orange and red through to indigo and violet, all the colours of the rainbow each have their own energy. And this is why, when sunlight hits a raindrop, it scatters all the colours into a rainbow in the sky. There are other types of light, invisible forms of light, that also have different energies. So if you think of X-rays that doctors use, these invisible rays have very high energy and can go through our flesh and show the bones underneath. Or there are much lower forms of energy, like mobile phone signals. They're also a form of light that are invisible, and they're so low in energy that we can safely keep mobile phones in our pockets. But when we think of colour, we really think of the forms of light that are visible, that we can see with our eyes, all the different colours. And the story of colour is really the story of life on Earth. To start the story, we have to go back 2,000 million years to when Earth was a very different place. There was land and there was sea, but there were no plants and no animals, because there was no breathable air. It was barren and dusty and silent, but there was life on Earth. There were bacteria, what we call germs, and the bacteria colonized the Earth, living wherever they could, where it was warm or moist, or where there was the right chemical cocktail. And different bacteria lived off different chemicals, and so they had different colours. The star of our story is a blue-green bacteria, a blue-green type of slime that we still have today. You'll see it underneath a dripping tap. And it was bluey green because of a particular chemical in it called chlorophyll. And the chlorophyll absorbed the red light from the sun, took it in, and left the blue and yellow and green light, and so that's why chlorophyll looked green. And about 2,000 million years ago, the blue-green bacteria did something very special. It just so happened that they started linking up their blue-green chlorophyll with their own internal energy machinery. And they started taking that energy from the sun through the chlorophyll and turning it into their own energy. So they no longer needed the chemicals from the earth to feed off, which was good for the blue-green bacteria, but it was very good for planet Earth, because the waste byproduct was oxygen. And slowly but surely, these blue-green bacteria started puffing out oxygen, making the air breathable. And it took another 1,000 million years or so, but eventually the Earth was a very different place, because with breathable air, all kinds of more complex life could come about. So there became plants and trees and creepy crawlies and woolly mammoths and humans. And all of us depend on the oxygen from the chlorophyll. Nowadays, chlorophyll is mostly in green plants and in the leaves of trees, and they are all producing the oxygen that we need every day to breathe and to live. But plants have learned that colour can do lots of other things as well. They have learned that colour is the code by which plants can control animals. Plants can't move, so to disperse their pollen or their seeds, they have to use animals. And they've learned that colour can help with this. So some plants produce flowers with very brightly coloured flowers and attract bees or insects who come and take the pollen away. Other plants produce brightly coloured fruit, which animals like us, hungry humans, love, and we therefore take the seeds and spread them around. So what is it about colour that lets plants do this? It's because animal brains are excited strongly by colours. Brains like our own, respond to colour in a very special way. A bit like we respond to smell and to music, we also respond to colour. So when we see a colour, we have a very particular response. Blood is red. It's panic. It's danger. Red means stop. How about brown? What does brown mean to you? Maybe brown is chocolate or coffee. But to me, brown is gazing into the eyes of the woman I love. And so each of us have our own special feeling when we see particular colours. So we can agree that red light is low in energy and blue light is higher in energy. And we can agree that different pigments exist and we can make pigments and give things a certain colour. But when it comes to feelings and memories, only you know what colour means to you.